So hello and good day. So now we're gonna be doing a little bit of CoolProp. So we use CoolProp. This is an extension or uh, an external application for Excel. So we're just gonna break down the basics. So here I have here on my screen. So CoolProp. So here's how we're gonna break down the formula. So we're gonna use the code string command props si parenthesis output input 1 value 1 input 2 value 2 and fluid. So please take note of the following. So please take note of the apostrophe, the quotation marks, the comma, and the parenthesis itself. So let's break it down first. So uh, PropsSI, that's like our command. So that's what we use to call the command itself. If we want to use the command, it's like we're gonna say, "Oh, PropsSI, come here. We need you to do this." So that's our calling command. Then we have the output. So what do we want to solve or what do we want to get? So let's say, for example, I want to get the temperature or the pressure of this thing. No. So input one, sign or symbol corresponding to CoolProp. So let's say, for example, uh, we are looking for the critical pressure, critical temperature, specific volume. So, and we're given with the temperature, so we're gonna put T for temp, then P for volume, then the other corresponding symbols or letters for each of those given to us. So we also have value 1, so that's the value that we're going to use. So CoolProp has its own default values that it uses. So let's say, for example, for temperature, it uses Kelvin, or for Pascal, for pressure, it uses Pascal. So we need to take note of that. So if the thing that we're given to us, or the value that we're given to us is in Celsius, we need to add 273.15 Kelvin to make it to convert it into Kelvin. So yeah, and then input 2 is the same thing. So what do we want to put in the CoolProp? Then value 1. So so this one's supposed to be value 2. So what kind of value we're going to use? So yeah, for example, 0 for saturated liquid or 1 for saturated vapor. So it depends on the given. So we also take notice of the context of the given. So let's say, for example, we were given a water that is around 10 degrees Celsius. So we know that if water is around 10 degrees Celsius, then it's most probably on its saturated liquid form. But if it's around 110, 115, 130, or around, 160, then it might be vapor because, well, it's evaporating. So, yeah, we have here an example. So, let's say we want to get the pressure in Pascal. So, this is going to be our command. So, props SI P T, then we want to get the pressure. So, here is our given. So, we have the temperature, which is 5 degrees. So, here. T is our first given temperature. Then we were given a 5 degrees Celsius, but CoolProp uses Kelvin, so we're gonna add 273.15 to that equation. Then we're given the quality of fluid or sample. So since it's on 5 degrees, we assume that the water was given in basic liquid form, since water cannot be ice or steam on that temperature. So let's try that out. So let's just copy this for one. Let's use this. This is for our exam assignment. So let's say, for example, we're given with that given. So let's call in props SI. Then we're looking for the pressure, and what we're given is temperature. Then the value of temperature is 5 degrees Celsius plus 273.15 to make it Kelvin, comma, we're given quality, and the quality is, let's go back, the quality is 0, because if it's 0, based from our notes, 0 is for saturated liquid and 1 is for saturated vapor. So we assume that it is on its liquid form, since it's 5 degrees Celsius. So it's gonna be 0. So that's gonna be, oh, it's looking for a value. Oh, I think I forgot something. Yep. Also in the end, we need to put fluid. So this is the chemical or substance you are dealing with. So let's say, for example, this one we're talking about water. So let's go back here and add water. So let's hit enter. So now this is the pressure that we are looking for. So it's in pascals. Now let's say we want this answer in kPa or kilopascal. So we're just gonna copy paste it. Then we're gonna be dividing it by 1000. Why divided by 1000? That's how we convert something from pascals to kilopascals. We adjust the decimal units by 3. So just divided by 1000, make it easier. So now we have 0.872575 kPa or 872.7551 pascals. So this is here in our note. Yep. Or if you want to do it in kPa, since we want to divide it into or convert it into kilounits, we're going to be dividing it by 1000. It depends on what your professor given is asking you for. So yeah, basically that's it. Then for the other things that you're looking for, let's say for example you're looking for the peak rate or whatever it is, so you're just going to be changing all of these factors. So let's say for example we want to find this peak rate, this value 22064. So let's try it. So we want to do it in kPa. So what we're gonna do is, let's label it P. This is also P. This one's gonna be peak rate. So the peak rates formula is gonna be let's call PropsSI. So equal PropsSI. Then let's ask for the peak rate. I need the peak rate. Can you give me the peak rate? Then comma. So let's say we just need to put a dummy temperature on this one. So let's put T. Then let's say for example, because water's critical pressure is always constant, it's not gonna change depending on the temperature, because one way or another it's on that pressure. So yeah, so we can just place a dummy number. So let's say for example 300. Then let's say for example we have a Q or quality of water, which is let's say that's 1, since it's on its vapor form. Then comma water, because different chemicals or different substances have their own different critical point for temperature and pressure. So they're gonna be giving different answers as well. So Yeah, let's hit enter. So, oh, name. So what's wrong with our formula? So PropsSI P crit. So I think it's the same. P crit 300, comma Q 1. So let's change this to let's say Pascal. So since it's not working, let's just change it for the sake of example. So P, let's say P is given, then 101.325 Pascal is the as the um our base unit for Pascal. So 101.325 comma water. So it's still executing its name. I don't know. I need to put props SI. Sorry, I forgot. So here we go. Let's try this one without the changes that we did earlier. So let's just say this one is Q and this one is 1. So yeah, there we go. Can you see it? So now we want this in kPa. So let's just change it to PA for now. And we want this one in kPa. So it's gonna be divided by 1000 to derive the kilo unit. So now this is our critical pressure for water. So that's the same as this one. See? So that's the basics of CoolPropsSI. Now um, we also have different other commands to call. So we have H HA PropsSI. So this one we use it for um assessing or something that is humid on its sense, or let's say dry and humid air, dry and humid chemical, something like that. So we use HA PropsSI. So there's different types, but for now we need to master basic PropsSI command. So yeah, that's it. Oh, for the next lessons, we're gonna try to fill up this table. We're gonna try to solve some um a little bit more equations, make graphs, something like that. So yeah, stay tuned. Yeah, that's basically it.